Hi again, FOM 11 students. This is an answer key for the Lesson 9 homework, and it was called Selecting a Strategy. And just before we do the assignment questions, here is basically the strategy, guys. You have to ask yourself, do I have a 90-degree triangle or not a 90-degree triangle? Okay, and so a 90-degree triangle is also called a right triangle. It's got a little 90-degree box in it. Okay, and if you have that kind of triangle, there are two things you can use: the Pythagorean theorem, a squared plus b squared equals c squared, or the primary trig ratios, SOHCAHTOA. Okay. And you can actually also use angle sum of triangle equals 180. Okay, but that works in both situations, whether you have a 90-degree triangle or not. So angle 1 plus angle 2 plus angle 3 equals 180 degrees. That works for this situation and this situation. Okay. So those were our first three tools of trigonometry. Excuse me. And then if you have the situation where it is not a 90-degree triangle, so some sort of triangle like this without the 90-degree box, then we can use the sine law and the cosine law. Okay. And the cosine law is basically if you have 8, 11, and 13, if you have three sides, or if you've got, say, 11 and 13 and the angle in between, two sides and the angle in between. That's when you use the cosine law, and you use the sine law if you've got, you always have to have what's called an angle-side relationship. So say this angle and this side, and then perhaps some other side over here, and then we can get this angle. Okay, or you could have this angle and this side, and then maybe some other angle. Let's say that's 38 degrees, and then you could get that side. Okay, so that's really kind of the strategy that we have, guys. So let's do the assignment. And it says, number 1, find the indicated side or angle. And in A, it wants us to find LM, which is this side right here. And I ask myself, do I have a 90-degree triangle or not? They are showing a 90-degree triangle, so I'm thinking to myself, either Pythagoras or SOHCAHTOA. And you can only use Pythagoras if you know two of the three sides, and we only know one side. So this is SOHCAHTOA. I want to get this LM, which is across from the 90. So we're looking for the opposite side. Sorry, across from the 90 is the hypotenuse. And this is the angle we have. We've got that side over there, which is the opposite. Okay, so I'm going to use opposite and hypotenuse. And that comes from the sine ratio we can see. So you would just go sine of 19 degrees is equal to 10 over the hypotenuse, which we could call x. Okay, and remember when you have this type of equation, those two things switch. So x is equal to 10 divided by sine 19 degrees. And since the angle is in degrees, make sure that your calculator is in degree mode. Yes, mine is. So I'm going to go 10 divided by sine 19, and we get 30.7 if we go to one decimal place. And notice that the 10 is in millimeters, so that is going to be millimeters. So there's the answer to 1A, and you can see that's consistent with the answer key. Okay, letter B, they want us to find side length ST. Okay, is it showing a 90-degree triangle, 90-degree box? No. Okay, so that means likely sine law or cosine law. And the cosine law you can use when you have an angle between two sides. And remember that you just have to label the angle that you know as A, and then that makes this little a over here that we're trying to find. And then it doesn't matter how you label B and C. So cosine law, we would go a squared equals b squared plus c squared minus 2bc cos A. B is 7, so we go 7 squared plus 11 squared minus 2 times 7 times 11, and cos the A is 112 degrees. Seven squared plus 11 squared minus 2 times 7 times 11, and then cos 112. And we get 227.68 and a bunch of stuff. And to get A by itself, I have to get rid of the squared, so I have to square root both sides. And the answer that works could be plus or minus of that. And so A is equal to plus or minus. I'm going to go second function x squared to get square root. And then you have to go second function negative key to get the word answer in there. We square root that, we get 15.1. We are finding a side length, so we're going to reject the negative answer, and we will just say that A is 15.1 millimeters. Okay, right on with the answer key. All right, letter C. They want us to find angle I. Okay, they are not showing a 90-degree box, so that means sine law or cosine law. And the sine law is good if you have what's called an angle-side relationship, an angle and its opposite side. So then we can get angle I using its opposite side there as well. So we could call this A and little a, and this B and little b. Excuse me, and you can say sine A divided by A is equal to sine B divided by B. So I would simply go sine of 70 degrees divided by its opposite side, which is 42, equals sine B divided by its opposite side, 36. Okay, so we have to get sine B by itself first of all, and it's being divided by 36, so multiply both sides by 36. So sine B is equal to all of that, which is 36 times sine 70 degrees divided by 42, 0.805, and a bunch of stuff. And so then angle B is sine inverse of that. So I go second function sine, and I want to put the answer in there, so second function negative key. See that little word answer in yellow is underneath, and the answer is 53. But with degrees, we go to the nearest degree, so 54 degrees approximately. Okay, and you can see that that is consistent with the answer key. Okay, letter D, they want us to find angle X. Hey, we have a 90-degree triangle, so that means Pythagoras or SOHCAHTOA. Pythagoras is only good for finding sides, so we're going to use SOHCAHTOA. And so if we want to find angle X across from it, this is the opposite side. Across from the 90 is the hypotenuse, so this must be adjacent. So we're going to have to use adjacent and hypotenuse, and that is the cos ratio. So cos X equals 15 over 17. And so angle X is cos inverse of that ratio. Shift cos 15 over 17, and we get 28 degrees. Okay, looks good in the answer key. In letter E, they want us to find HG, so they want us to find a side right here. We do have a 90-degree triangle, so Pythagoras or SOHCAHTOA applies, and when you have two of the three sides, you can do Pythagoras. All right, across from the 90 is C. This is A. We can call this B. That's the one we're trying to find. So A squared plus B squared equals C squared. And we have 16 squared plus B squared equals 34 squared. We have to get B squared by itself. We're adding 16 squared to it, so subtract 16 squared from both sides. And we've got positive B squared equals, let's work that out, 34 squared minus 16 squared. And we get 900. Just want to give myself a little bit more space here. Get rid of squared, we have to square root both sides. Plus or minus could work. And b equals plus or minus the square root of 900. Second function x squared, second function negative. Square root of 900 is 30. We're finding the length of a side, so we'll reject the negative answer, and we will say that b is 30 meters. Okay, and that is consistent with the answer key. Okay, and in number 1, goes on for a little bit more. So here is letter F. Find angle A. They're not showing a 90-degree box, which means sine law or cosine law. And remember we said the sine law is only good if you have an angle-side relationship, but we don't know any of the angles, so that one's out. So it's got to be cosine law. And we want to find angle A right here. So label the angle you want to find as A. The opposite side over here will be little a, and then it doesn't matter how you label B and C. Oh, I'm trying to do the cosine law here. A squared is equal to B squared plus C squared minus 2BC cos A. And remember, to get cos A by itself, I usually give you this formula for cos A. It would look like this. Should be A squared minus B squared minus C squared. All divided by negative 2BC. So let's figure out what that is. That's going to be 37.1 squared minus 62 squared minus 65 squared. Negative 2 times B is 62 and C is 65. Okay, so let's work out cos A. So I'm in brackets, I'm going to go 37.1 squared minus 62 squared minus 65 squared, and divide that by negative 2 times 62 times 65. Close that. 0.830. A bunch of stuff. So then angle A is equal to cos inverse of that. So I go second function cos and then put in that answer, and we get 34 degrees. Okay, so 1F is 34 degrees. Okay, which looks good. Okay, letter G, find UV. Okay, so they want us to find this side. We could call it x. Hey, we have a 90-degree triangle, so that means I could do Pythagoras possibly or SOHCAHTOA. Pythagoras is only good if you know 2 of the 3 sides, and we only know 1. We know a side and an angle, so that's SOHCAHTOA. So here's our angle. What we're trying to find is the opposite side. Across from the 90 is the hypotenuse, so this must be the adjacent. So I'm going to be working with opposite and adjacent. Opposite, adjacent comes from tan. So I would just go tan of 25 degrees equals x over 12. Okay, and to get x by itself, we just multiply both sides by 12. Okay, so x is equal to 12 times tan, 25, and we get 5.6 centimeters. Okay, and letter H wants us to find x. We only know one side in the triangle that x is a part of. So if we could get this side over here, then we could use Pythagoras. And that's kind of the plan of attack, because in this first triangle, there is no 90-degree angle showing, which means you have to use the sine law or cosine law to get other sides and angles. And we've got an angle between 2 sides, so cosine law. And what you can do is, in the cosine law, the angle that you know or want to know is labeled A, which means that this side over here that would be beneficial if we found, this would be little a. So let's find little a using the cosine law, and then we'll use Pythagoras to get x in the other triangle. Okay, so if that side is A, it doesn't matter how we label B and C. A squared is equal to B squared plus C squared minus 2BC cos A. B is 12, so we would go 12 squared plus 34 squared minus 2 times 12 times 34, and then cos 73 degrees. $12 squared plus 34 squared minus 2 times 12 times 34 cos 73. Okay, so 1061.42 and a bunch of stuff. Let's square root that. Square root, plus or minus. So A is equal to, get that square root symbol up, and then put answer in there, and we get 32.6, let's say. Okay, so I guess technically it's plus or minus 32.6, but since it's a length of a side, we'll reject the negative and we'll say 32.6 meters. Okay, so that gives us A right over here. So now in the 90-degree triangle, we'll use Pythagoras to get x. So this is 32.6. And remember, across from the 90, that's the c. So we will go c squared is equal to a squared plus b squared. So this will be our b over here. C squared is equal to 32.6 squared plus b is 9 squared. So c squared is equal to, wonder how they're going to do the rounding. Maybe if we just try 32.6 squared plus 9 squared, and we get, 1143.76. And then square root, square root. Hey, look at that. C is plus or minus 33.8. So C is equal to 33.8 meters. Which is consistent with the answer key. Okay, let's get on to number 2. It says a tower is supported by 2 guy wires that are attached on the same side of the tower and in a line with the base of the tower. Okay, so here's the base. And then they're attached here and here, right? The wires. The wires are 810 meters and 650 meters long. The shorter wire makes an angle of 65 degrees with the ground. At what angle does the longer wire meet the ground? Okay. So they want us to figure out this angle right here. Okay. Okay, so what we're going to have to assume is that this is a 90-degree angle right here. All right, and so I think what the plan of attack is here, guys, is we're going to use this first 90-degree triangle to get the height of the tower, which is y. Okay, so we'll get that big side, which I've labeled y, and then we'll use that in this big 90-degree triangle here. I will use that, the y and the 810, and do SOHCAHTOA because the big triangle is a 90-degree triangle as well, and then we can do SOHCAHTOA to get this angle that I will call x, let's say. All right, so that's the plan of attack. So let's first of all figure out what y is. Okay, and so in this 90-degree triangle, I can use the 65 degrees. Across from it is the opposite. Across from the 90 is the hypotenuse, this one here. Opposite and hypotenuse comes from sine, so I'm going to go sine of 65 degrees equals y divided by 650, and then multiply both sides by 650. Okay, so y is equal to 589.1. So this is 589.1, and that's going to be in meters. And now we're going to use the big triangle here. It's got that 90-degree angle. Okay, so this is what I'm doing. I'm going to forget about the wire in between. I'm going to call this angle x that we're trying to find. This is 810 meters, and this is 589.1 meters. And then we can go, hey, side over here is opposite angle x, and across from the 90 is the hypotenuse, so I'm going to use sine again, and I'm going to say sine of angle x is equal to 589.1 divided by 810. So x is sine inverse of this ratio. And let's see what we get. Second function sine, 589.1. divided by 810, and we get an angle of 47 degrees. Bang on, if you look at the answer key. Okay, here's number 3. A pilot is headed to another town from his home airport. He travels 120 kilometers due east. He turns at an angle of 135 degrees. He continues northeast for 100 kilometers until he reaches the town. What is the straight line distance from his home airport to the town? Okay. No 90-degree triangle, so that means sine law or cosine law. Sine law is good if you have an angle-side relationship, which we don't. Cosine law is good if you have an angle between two sides. Okay, and we do want to find the distance from his home airport to the town. So we do want to find this distance that is across from that angle. So we label the angle A, and we are looking for little a, and then it doesn't matter how you label B and C. So you have a squared is equal to b squared plus c squared minus 2bc cos A. Okay, let's work this out. 120 squared plus 100 squared minus 2 times 120 times 100 times cos 135. 41370. .56275. Excellent. So, square root, a can be plus or minus of that. Second function x squared to get square root, and second function negative sign to put in answer, and we get a is 203.4. So a is equal to 203.4 kilometers. Perfect. Answer key looks good. And then part B says, on what bearing angle from north must the pilot fly to reach his destination in the shortest possible distance? Okay, so we'd have to go right along that straight line from the home to the town. And so the angle from north is this one. Okay, and so what we need to do is we need to figure out this little angle here and realize that this whole thing is 90. So we'll go 90 minus that little angle that I'm putting question marks by, and that will leave us with the angle from north that we're looking at. Okay, so inside the triangle doesn't have a 90-degree angle. We only know one angle. We're going to have to use sine law or cosine law. And since we know A now, that this is 203.4, we have an angle side relationship, so we can use the sine law. And we could go sine of angle A divided by little a is equal to, I want to find this angle right here, which is across from little c, so it's going to be capital C. So that will be sine c divided by c. So I'm going to go sine of 135 degrees divided by little a was the 203.4 that we found. We're trying to find angle C, and little c is the 100 kilometers there. Okay, so I want to get capital C by itself. The sine function is acting on it, and then we're dividing by 100, so I'm going to multiply both sides by 100. Sine C is equal to, we'll work all that out, 100 times sine 135 divided by 203.4, 0.347. And so then C is sine inverse of 0.347. Oops, kind of wrecked that. 100 sine 135 divided by 203.4. Second function sine, and answer 20.3, or it's an angle we're finding, so 20 degrees. Good. Okay, number 4. A triangular park has sides of length 200 meters, 155 meters, and 172 meters. Determine angle A. Okay. We could do that using the cosine law. Determine H. Okay, we can figure out that. Once we figure out angle A, and we'll go from there. Okay, so to figure out angle A, I'm going to use the big triangle here that doesn't have a 90-degree angle. And when you use a triangle like that, it is either sine law or cosine law. And it's cosine law when you know all three sides and no angles. All right, so here's what we're going to do. We're looking for angle A. Label it A, nice. Across from angle A is little a, and so then B and C don't matter. And remember, the formula for sine A is a squared minus b squared minus c squared, all of that divided by negative 2bc. A is 172 squared minus 155 squared minus 200 squared. And on the bottom we have negative 2 times 155 times 200. Okay, so sine A is equal to 172 squared minus 155 squared minus 200 squared. Negative 2 times 155 times 200. .5555. Awesome, so angle A is sine inverse of that. Anyway, so shift sign of that answer, and we get 34 degrees. So angle A is 34 degrees. Oh, haha, I made a mistake, didn't I? I was using cosine law, so these should all be cosines. Cos A is equal to all this. Sorry about that. So then this will be cos inverse. Cos 0.5555, and we get 56 degrees. Okay, and that looks good with the answer key. There we go. 56 degrees. And I just want to go back to number 3 for a second, because I just want to make sure we answered the question here. Because we got the answer in the answer key, but we got this angle right here, which is 20 degrees. We didn't actually answer on what bearing angle from north that would be. And the answer key didn't do it either. They just got that little angle C. So actually the angle from north would be this one. And since that's 20 and the whole thing is 90, the angle from north is 70. Okay, so on what bearing? The bearing angle should equal 70 degrees, angle from north. Okay, but even the answer key didn't take that extra step. Okay, back to number 4 here, determine H. Now we can figure out H because I have an angle and a side in a 90-degree angle, which means I can do SOHCAHTOA. The angle opposite 56 is the opposite. The angle opposite the 90 is the hypotenuse. So I'm going to deal with opposite and hypotenuse, so that is sine. So sine of 56 degrees is equal to H divided by 155. Multiply both sides by 155. H is equal to 155 sine 56. Okay, so H is 128.5. That is meters. And that is consistent with the answer key. Calculate the area of the park. It's a triangular park. The area of a triangle is base times height divided by 2. The base is this. There's the base, and there's the height, h. So the base is 200 meters. The height is what we just figured out in part B, 128.5 meters, and then divide that by 2. 200 times 128.5, divide that by 2, and we get 12,850, which is consistent with the answer key. And that's going to be meters times meters, so square meters. Excellent. We only have 2 left to do here. Number 5, what is the method used to find AC in the triangle below? So we're wanting to try to find AC. The angles in a triangle have to add to 180, so if you go 180 minus 72 minus 65, we get 43. They weren't showing a 90-degree box, but I just wanted to check to make sure. So it's not a 90-degree triangle. And when you don't have a 90-degree triangle, it has to be either sine law or cosine law. So that gets rid of Pythagorean theorem. We didn't even talk about a tangent law. So it's either sine law or cosine law, and we want to get AC if we called it x. We have an angle and its opposite side. And then we have another angle here, so we could go sine A over A equals sine B over B and use the sine law. Okay, so that's 5C. And the answer to 5 is C. And number 6, from a certain point, the angle of elevation to the top of a church steeple is 9 degrees. At a point 100 meters closer to the steeple, the angle of elevation is 15 degrees. Calculate the height of the entire structure. Okay. Okay. All right, so what's our plan of attack? We want to figure out this height ultimately, and we can assume that that's a 90-degree angle. So if we could get a side in this triangle, then we could use SOHCAHTOA to get the height. Or if we got a side in the big 90-degree triangle, that would work. Like if we figured out this side over here, maybe. Okay, and we can do that because we can figure out this angle right here. If that's 15, notice that those two angles make up a straight line. You'd go 180 minus 15. So this would be 165 degrees, and we could call that angle A. And since we know that that's 9 degrees, 165 plus 9 is that. The remaining angle to make 180 you'd have to add another 6, so this would be 6 degrees here. Okay, so I've got this angle B and its opposite side 100, and then I've got angle A and a missing side, so I can go sine A over A is equal to sine B over B. Angle A is 165 degrees. Little a is what we're looking for. Sine B, angle B is 6 degrees, and little b is 100. Okay, remember how we solve this? Cross multiply first of all. And then we want to get A by itself, so divide both sides by sine 6. Okay, so A is equal to 100 sine 165, and then divided by sine 6, and we get 247.6. That's going to be meters. So this is 247.6 meters, and then I'm going to use this whole big 90-degree triangle with the 9-degree angle. You kind of forget about the stuff in the middle. Across from the 9-degree angle is the opposite. Across from the 90 degrees is the hypotenuse. So opposite and hypotenuse, I'm going to do sine. Sine of 9 degrees is equal to opposite divided by hypotenuse. And to get h by itself, multiply both sides by 247.6. H is equal to 247.6 times sine 9 degrees, and we get a height of 38.7 meters. .7 meters, okay, which is perfectly good with the answer key. All right, there you go, everybody. Answers to Trig Lesson 9 right there. And that is actually our last lesson for trigonometry. And so next week what I'll do is I'll send you a review for the unit with a video answer key, and I'll also send you a unit test that you can do open book and send back to me. All right, thanks everybody. I will talk to you soon.